Assalamualaikum and good day to everyone, especially to the 6th International Conference on Industrial, Mechanical, Electrical and Chemical Engineering audience. First of all, I would like to thank to the Akimiki 2020 committee for inviting me as one of the speakers for this international conference event. My name is Nur Azmah Nordin from University Technology Malaysia, Kuala Lumpur, Malaysia. And today I would like to share with all of you about my research area that basically related to the magnetic responsive materials or known as magnetorheological materials. Magnetorheological materials or MR materials is a kind of polymer composite that consists of magnetic particles which are embedded or suspended in the polymeric base matrix. Due to presence of these magnetic particles in the polymer base matrix, when applying magnetic field onto these MR materials, the magnetic particles would align according to the magnetic polarity in the direction of applied magnetic field. Therefore, the properties of MR materials in terms of stiffness and viscoelastic or viscoplastic can be tuneable or changeable according to the strength of magnetic field. Overall, MR material is a smart material that very sensitive towards the applied magnetic field. There are few types of MR materials depending on the matrix-based polymer. If the magnetic particles are suspended or distributed in the carrier medium of fluid, then the MR material is known as MR fluid. If the magnetic particles are embedded or locked in the elastomer or rubber-based matrix, then the MR materials is known as MR elastomer. Same goes to MR foam, in which the magnetic particles are embedded in the strut of foam or suspended in the pores of foam. Similarly, with the MR grease or MR plastomer, in which the magnetic particles are suspended in the medium of grease, or plastomer or plasticity polymer-based material. There are so many things that can be done on each of MR materials in order to meet specific requirement for specific application. Playing with the different kind of magnetic particles, the shape, the sizes, or combination between these two parameters, different carrier medium, composition either for magnetic particles or carrier medium, or playing with the additives in terms of nano size or micron size, that all of these parameters are known to cause changes in the structure of MR fluid that subsequently would affect the resultant behavior or properties of these MR materials. Similarly, with the devices or application of MR materials, the value added can be focused on design or concept of the device, magnetic circuit or coil arrangement in order to control the magnetic flux that pass through into the materials as well as to the system, the simulation or modeling that can be used to predict the output after modification onto the materials or the devices, the process, the vulcanization type or system integration, that all of these focus would bring to various output that meet the requirement and for various purposes. Now let's go to see briefly each of MR materials. MR fluid, or known as Magnetorheological fluid, is a first MR group that discovered in 1940s by Rabino. Contains of iron particles in the carrier medium of fluid or oil. This MR fluid basically just like a normal fluid. Same goes to the Milo that consists of Milo powder in a diluted milk. When there is nothing special about it, especially when there is no magnetic field applied onto this MR fluid. But in the presence of magnetic field that induced into this MR fluid, the magnetic particles of iron that we know respond to the applied magnetic field would align according to the magnetic flux line passed through into this MR fluid. Prior to this changeable of MR fluid in millisecond, MR fluid has a wider potential to be applied in various applications depending on the working modes as shown here, either for flow mode, squeeze mode, shear mode, or combination between these three modes. So MR fluid can be applied for MR damper, turbocharger actuator, MR hybrid MR damper composed of multiple modes, and also has a potential to be applied for rehabilitation for stepper and bicycle exercise that focus on compact MR brake. Next MR group is MR elastomer or Magnetorheological elastomer. MRE is a solid analog to MRF in which the carrier medium of fluid is replaced by elastomer, composed of magnetic particles that lock in the rubber-based matrix. There are two types of MRE known as isotropic and anisotropic. For isotropic type MRE, the magnetic particles are distributed randomly within the rubber-based matrix. Meanwhile, for anisotropic MRE, this MRE is related to the aligned particles that have been locked in the rubber-based matrix, respective to the magnetic field applied during curing of MRE. Similar with the MRF, MRE also possess controllable stiffness and changeable elastic modulus, respective to the applied magnetic field, and the behavior can be controlled and tuneable continuously, rapidly, and reversibly. However, due to lock of magnetic particles in the rubber-based matrix, when applying magnetic field onto this MRE, magnetic particles would tend to vibrate only according to the magnetic polarity of applied magnetic field, unlike MRF that has movable particles in the carrier medium of fluid. This is the condition of MRE that has been mentioned earlier. Vulcanization or curing of MRE would determine the type of MRE at the end of the curing process. If there is absence of magnetic field during curing of MRE, then the iron particles would embedded or locked in the rubber-based matrix in randomness manner. However, then it is called as isotropic. However, when there is magnetic field applied during curing of MRE, then the magnetic particles would be locked in the rubber-based matrix in aligned manner, and it is known as anisotropic-type MRE. Then comes to application of MRE, divided into three main areas as shown here. MRE has a potential to be applied as vibration and noises controller, actuators, and smart sensing devices. Next MR group is MR foam or Magnetorheological foam. Similar with the MRE, MR foam possess controllable stiffness or properties due to presence of magnetic particles either in the strut of pores or in the strut of foam or suspended in the pores of foam, respective to different fabrication method of this MR foam. However, presence of this iron particle in the strut of pores has caused the size of pores can be tuneable or changeable by magnetic field that apply onto this MR foam. Therefore, MR foam can be seen as a candidate for smart vibration and acoustic absorbing materials. Besides, very small deformation possessed of this MR foam, especially respective to low magnetic field applied to this MR materials, MR foam is seen to be potential to apply for magnetostrictive sensor for soft robotic hand has shown here, especially for rehabilitation purposes. Next MR group is MR grease, or known as Magnetorheological grease. MR grease is another kind of MR group that has magnetic particles suspended in the carrier medium of grease. Has higher viscosity compared to MRF. MR grease is seen as a candidate to overcome the settling or sedimentation issue associated with MRF. Higher viscosity of MRG as well has enhanced its yield stress as well as the stiffness behavior of these MR materials, especially with presence of magnetic field. However, higher viscosity of MRG also cause slower response of this MR material towards the alteration of magnetic field, unlike MRF that can be faster response in 1 to 10 milliseconds. So that research on this MR grease is still continuing by adding additive or combination between differentiate of magnetic particles in order to enhance the transient response of this MRG towards the manipulating of applied magnetic field, so that it is more convenient to be applied for MR devices, especially related to the rehabilitation devices. So as you can see here, different MR group would possess or would exhibit different behavior, which later can be further modified for further refinement of the behavior or properties of each MR materials. Long way to go since MR materials still at the beginning stage, but I believe these smart MR materials has a brighter future for innovative smart devices and application. That's all from me. Thank you.